This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on graphing rational functions. So we're going to begin with f of x is 2x squared plus 6x minus 8 over x squared minus 4x minus 12. We want to identify the horizontal asymptote, so we look at the highest powers. They're both the same. Highest power upstairs, x squared. Highest power downstairs, x squared. So we know we have a horizontal asymptote. You take the ratio of those two coefficients. 2 divided by 1 is 2. So my horizontal asymptote will be y equals 2. Now, any more analysis is going to require me to factor. And you'll notice there's a common factor of 2 in the denominator. If I extract 2 from each of those three pieces, I will get 2 times x squared plus 3x minus 4. And that can be factored as well as the x squared minus 4x minus 12 can be factored. So what do we get there? X minus 1 times x plus 4 to give me x squared plus 3x minus 4. X plus 2 times x minus 6 to give me x squared minus 4x minus 12. Now, vertical asymptotes will be when the denominator is 0 and they don't cancel out. So when is x plus 2 equal to 0? When x equals negative 2. When is x minus 6 equal to 0? When x equals 6. So we have 2 vertical asymptotes and 1 horizontal asymptote. So we can draw those in. Vertical asymptote x equals negative 2. X equals 6. Horizontal asymptote at y equals 2. Next up, I want to find the x-intercepts, where it crosses the x-axis. I will do that by setting the y value, or f of x, equal to 0. So 0 will equal this function. Now, when does 0 equal a fraction? That happens when the numerator is 0. Of course, we can never divide by 0. So I need 2 times x minus 1 times x plus 4 to equal 0, which will occur when x is 1 or when x is negative 4. So those will be our x-intercepts. Both 1, 0 and negative 4, 0 will be points on the graph. And you can see I've identified those. 1, 0, negative 4, 0. Next, I want to find the y-intercepts. We will do that by setting x equal to 0. 0 minus 1, 0 plus 4, 0 plus 2, 0 minus 6. So f of 0 will correspond to the y-intercept. 0 minus 1, negative 1, 0 plus 4 is 4, 0 plus 2 is 6, 0 minus 6, negative 6. Negative 8 upstairs, negative 12 downstairs, and we get 2/3. So the y value will be 2/3 when the x value is 0. So we have the 2 x-intercepts and the 1 y-intercept that will help us work the graph. And there you can see the 0 2/3 is there. Now we need to discuss how we are going to graph this. We have 2 vertical asymptotes. Negative 2 and 6. They are order 1, first power, first power. So on either side of the asymptotes, they will be going opposite directions. So let's just kind of keep that in mind. We'll certainly graph a couple more points to give us some ideas, but down this way, down this way, down that way maybe. Let's take a look at what we get. So we want to find some additional points. I've chosen to look at negative 3, negative 1, 5, and 7 on either side of the vertical asymptote. So we've got to do some quick math here. F of negative 3 minus 1, negative 4, negative 3 plus 4 is 1. Negative 8, negative 3 plus 2, negative 1, negative 3 minus 6, negative 9. Negative 1 times negative 9, positive 9. So f of negative 3 is negative 8/9, pretty close to 1. Let's do negative 1 next. Negative 1 minus negative 1, negative 2. Negative 1 plus 4, 3. Negative 1 plus 2, 1. Negative 1 minus 6, negative 7. And we get negative 12 upstairs, negative 7 downstairs, or positive 12/7. Next one I chose to do was 5. 5 minus 1 is 4. 5 plus 4 is 9. 5 plus 2 is 7. 5 minus 6 is negative 1. 72 over negative 7 around negative 10. And then we'll plug in 7. And we get a very large number, 132 over 9. Let's get decimal approximations for this so that we can graph it more easily. So negative 3, negative 0.889, negative 1, 1.714, 5, and negative 10.286, 7, 14.667. Let's take a look at what those points look like on the graph. So we added those few extra points, and it gives us an indication of how this is going to behave. X plus 2, negative 2, asymptote of order 1, so different ways. Maybe coming from the left it's going down, but coming from the right it's going to go up. Same thing, 6 is an asymptote of order 1, so it's different on either side. From the left it appears as if it's going down, from the right it appears it's going up. We have this horizontal asymptote, so as I go to negative infinity, the function should get closer and closer to that. It doesn't cross because we've already established, well, actually it might cross. I've got to set it equal to 1. Or excuse me, to 2. But I'm not terribly concerned about that. It is tending towards 2 as it goes this way. And over here, this is going to tend towards 2, so we're heading up to the left, heading down this way. So that's my guess for the graph, and let's see how close that guess is. Indeed, you can see the behavior happening the way we expected. Negative 2. From the left going down, from the right going up. At 6, from the left going down, from the right going up. They have to be different because, again, those are first order asymptotes. Okay, let's take a look at our next question. We've got f of x is 3 times x minus 2 times x plus 4 over x plus 1 squared times x minus 3. Okay, if I multiply this out, I'll have 3x squared plus stuff upstairs. I'll have 1x cubed plus stuff downstairs. This is a bottom-heavy fraction. The degree of the bottom, x squared times x cubed, is bigger than the degree of the top, x squared. If the degree of the bottom is greater than the degree of the top, we know we have a horizontal asymptote at y equals 0. What about our vertical asymptotes? When the denominator is 0, at negative 1 and at 3, but they're going to behave differently. Negative 1 will behave like an order 2 asymptote. So from the left and from the right, they're heading the same direction. X equals 3 will be an order 1 asymptote. From the left and from the right, they will be heading different directions. But let's continue our analysis. What do we get next? Vertical asymptotes, when this is 0, x equals negative 1. Vertical asymptote, when this is 0, x equals 3. But again, different types of asymptotes. My next goal is to find the x-intercept, so I'm going to set y or f of x equal to 0. If a fraction is 0, the top is 0. So therefore, x would be 2 or negative 4 when y is 0. So those points would give me 2, 0, and negative 4, 0 would be my x-intercepts. To find the y-intercepts, I'm going to set x equal to 0 and see how that behaves. 0 minus 2, 0 minus 4, 3 times negative 2 times 4, 0 plus 1, 0 minus 3, 1 squared, negative 3. Upstairs, negative 24. Downstairs, 1 times negative 3, negative 3, and we get 8. So the y-intercept occurs at 8. As a point, it is the point 0, 8. So currently I have 1 horizontal asymptote, 2 vertical asymptotes, 2 x-intercepts, and a y-intercept, as well as knowing the behavior of those asymptotes should be able to give me a chance to draw a reasonable sort of graph. So everything is labeled. X-intercept, x-intercept, y-intercept, asymptote here, asymptote here. So we might guess how this is going to behave. It certainly appears as if it's going up this way, so I would assume it's going down this way. X equals 3 is an order 1 asymptote, so it can't be going down. It's got to be going up. So I'm going to assume it's going to kind of behave this way. And again, this is going up. X equals negative 1 is an order 2 asymptote, so I'm going to assume that is going to be going up as well. So let's see if our numbers verify that idea. So we're going to add a couple more points on the graph just to give us some more information. Plugging in negative 3 minus 2 is negative 5 times 1, negative 15 upstairs. Negative 3 plus 1 is negative 2 squared is 4. Negative 3 minus negative 6 is negative 3 minus 3 is negative 6. 4 times negative 6 is negative 24. Negative 15 over negative 24, 15 24ths, which of course you could reduce, but I'm not terribly worried about that. Plugging in negative 6, same sort of thing. We get negative 48 over 225. And plugging in 4, I get 48 25ths. So I thought this might give me enough information to sort of graph it. Let's get some decimal approximations to see where these are, and let's add those points again to see where we are. So I've taken my x and y intercepts, my asymptotes, as well as those 3 points to get an idea of what this function is going to look like. So we know we have a horizontal asymptote. It is a bottom-heavy fraction. It's going to go to 0. So even though this passes through 0, this is going to continue fairly close to 0 and then shoot up this direction. It's pretty obvious here this is shooting up this direction as well. Now if they're both shooting up at -1, that would indicate that it is an order 2 asymptote, which is what we have. But at x equals 3, it's an order 1 asymptote, so what's happening there? If it's shooting down this way, we'll assume it's going up that way. We have a horizontal asymptote at the x-axis, so it should be coming down like this. So let's see how good my prediction is. And you can see that it is pretty good. So we don't want perfect graphs. You don't need all the points to be correct, but we want to hit the major features to identify that we understand the analysis. Let's take a look at one more problem. This time I have f of x is -4x squared minus 4x plus 24 over x squared plus 8x plus 15. We start with the highest powers. They are both the same again, so we're going to have a horizontal asymptote. The ratio of the coefficients, -4 divided by +1, is -4. So our horizontal asymptote will be y equals -4. Now to do the rest of the analysis, we are going to need to do some factoring. And you'll notice we can factor in -4 out of each of those. If I factor -4 out of this, I get 1x squared. Out of this, I get 1x. Out of this, I get -6. So -4 times x squared plus x minus 6 over x squared plus 8x plus 15. Now let's factor each of these. And we get -4 times x minus 2 times x plus 3 over x plus 5 times x plus 3, and you will notice that the x plus 3's divide out. Now, x equals -5 and x equals -3 are not in the domain. X equals -5 will be a vertical asymptote, because that sticks around. But the fact that the x equals -3 divides out tells us there will be a hole at x equals -3. Not enough for us, though. We also need to find out what the y value is for that hole. So we had this function originally, our 2 asymptotes, we know where the hole is. Dividing that out and then canceling or dividing out the x plus 3, I get f of x now is -4 times x minus 2 over x plus 5. Remembering x really cannot be -3. But plugging -3 into this version, -3 minus 2 is -5, -3 plus 5 is 2. We get 20 over 2 or 10. Now again, this is not on the function. -3 is not in the domain, so I guess this is a bit of an abusive notation. But that tells me where the hole is located. The hole is located when x is -3 and y is 10. So again, we have 2 asymptotes and we have a hole. What else do we need to do our analysis here? Let's go ahead and find our x-intercept. As usual, we're going to set y equal to 0. So we're going to get 0 is -4 times x minus 2 over x plus 5. If a fraction is 0, the numerator is 0, and that only happens when x is 2. Of course, x minus 2 is 0, x is 2. And to find the y-intercept, we are going to set x equal to 0. So doing that, -4 times 0 minus 2 over 0 plus 5, and I get 8/5. So we have 2 asymptotes, a hole, a single x-intercept, and a single y-intercept. So we want to go ahead and look at this to determine what is the graph going to look like. So if we look at this version, -4 x minus 2 over x plus 5, we're saying x equals -5 is going to be our asymptote of order 1, so it's going different directions on each side. From the right, boom, boom, through the hole that way, it certainly appears as if it's heading up, coming from the right. And then we have to come down like this to get to the horizontal asymptote. Now, we don't have any points over here, but you certainly could plug in -6, -7, -8, -10, -15 to see what the behavior is. But we know that it is going in a different direction, so it's got to come down from the left since it's an order 1 asymptote. It's going up from the right, it's got to go down from the left. So our best guess is it looks something like this, down from the left, and then heading up towards the horizontal asymptote. How good was that prediction? Pretty darn good. And again, if you want more points, you can get them, but my main focus is that you understand the behavior of the functions. And that will complete this lesson.